Welcome to example 4. We're going to be looking at a question in context where we're going to be looking at the zeros and they, if they make sense, interpreting them in the context of the question. So first thing here is we're selling lamps, specifically lava lamps. Okay, that's a little different than just lamps. Giving you the graph and giving you the function, although as we'll get to the end here, I think this actually should be a minus. And you have no way to know that until something that happens at the end. But anyway, so what do the zeros tell you about that? Well, the zeros appear to be at -2, and then 3, and then 10. Based on where the zeros are, you can get the factors. The factor theorem that they're referring to at some point in the notes. Oh yeah. Then by the factor theorem, you can determine the factors that come from those zeros. Well, remember the factor theorem is if let's say a is a 0, then x minus a is the factor that it came from. So if the 0 is -2, x minus -2 would be x plus 2, right? Essentially the signs swap. If the 0 is positive, then it's x minus 3 because it's x minus the 0, right? And same with 10, it'd be x minus 10. So those are the three factors that the three zeros came from, presumably from the graph that we're looking at. You can't just assume something by looking at a graph, because maybe it's like 1.9 and you're not seeing it, right? So there's a way to confirm that. The book's going to go through one way. I'm going to talk about a different way to do it as well, maybe even a third way. But they're suggesting take the factors and then multiply them together and see if you get what you started with. Well, you actually don't get exactly what you started with. In theory, again, assuming that was a negative on the 4x, you get exactly the opposite. What that means, though, is you have the same zeros. It's just coming at it in a different way. So what that confirms when you multiply these together, so you pick two of them, apparently they pick the second two, FOIL them, and then you distribute the x plus 2 into the x squared minus 13x plus 30, you get the same, well, I'm saying you get the opposite function, but that opposite function has the same zeros. So you're confirming that the zeros are good. Let's talk about some other ways that you can confirm that the zeros are good. Another way would be, and I'm not going to write this all out, but just demonstrate, you take the original function, which again, should have had that -4 in it, I think. And then you do synthetic division with each of the zeros that you think are correct. The 0 is a 0 of the function if through synthetic division you get 0 as a remainder. So that's another way to confirm it. The other way to confirm it is in the process of graphing. If you can actually on the graph identify the exact coordinates and show that the y coordinate is 0, then you have a 0. So when you go and do the next example, you can confirm it any of those ways that you want, and I'll demonstrate a couple of those ways as well. But this is one of them. Probably not the way I would choose, though. Okay. So then interpret what you've got. Well, if you look at the graph again, it's positive between the zeros of 3 and 10. So each value of x represents thousands of lamps sold, so or produced. So that means they should be producing between 3,000 and 10,000, right? Any less than 3,000, they're not making a profit. Any more than 10,000, they're not making a profit. In reality, you'd want to try to figure out what is this maximum point up here. We're going to get to ways to calculate that. For right now, we can just say they're making a profit between 3,000 and 10,000, and that's good information to have. The other 0 back here where it's -2, meaningless, right? Because you can't produce a negative amount um, of lamps. So you can't say like, oh yeah, well, they really maximize their profit if they made, negative 3,000 lamps. Well, that makes no sense. So in reality, we're only looking at first quadrant information here, because the X needs to be positive, and then you're also looking for the Y's that are positive. Certainly, if it is a realistic scenario that you could produce like 1,000 and you'd not make a profit, but that wouldn't be then beneficial to the company, even if it is a realistic possibility. Whereas like making negative uh, lamps would not even be in the realm of reality. All right, so given a similar function, um, I want you to figure out how many lamps should they make in order to make a profit. Your answer is going to be a range, like between this many and this many, they will make a profit. So what I would do is first graph the function, see where the zeros are, figure out a way that you're going to confirm that the zeros are actually the zeros that you're seeing on the graph, and then you can make an assessment of between what and what the company will make. Well, we're selling lamps again, so how many lamps they should make to make a profit. All right, so why don't you pause, give it a try, and then come back and I'll go through a couple different ways that I'm going to go get this answer. So the first thing I actually did is I went to Desmos and I graphed it. I just graphed this function that was given, zoomed in a little bit, but it comes in from the top, curves under here somewhere, comes back through, curves up here, and then comes back down forever. The 3 zeros. So this is honestly a way to confirm, because Desmos will give you the exact zeros, right? So they are exactly at -2, 1, and 11. So at this point, I know that those are the zeros because I'm seeing them precisely on the graph. If they were crossing it somewhere, like instead of 1, it was at 1.1, it would tell me that it was 1.1. It's not 1.1, it's 1. So the zeros are -2, 1, and 11. So you can use that information to confirm that those are the zeros. If you need to prove it algebraically, you could do what they did. You could take the 3 factors, which would be, well, it would be x minus each of the zeros. So you could multiply x plus 2 times x minus 1 times x minus 11 together, and you'll get either the function or the opposite of that function. If you want to do it a different way, let me walk you through what I did here. I just took the first 0 and I did synthetic division with the coefficients of the original function. What I ended up with was the 0 as the remainder. So that confirms that -2 was one of the zeros. You could keep doing synthetic division with each of the zeros back into the original, or take what you get out of the division. It has a negative in front. So what I did is I factored that negative out of each of the terms, -1 out of each of the terms, and then I was able to factor x squared minus 12x plus 11 and got x minus 11, which is the factor where the 11 0 came from, and x minus 1, which is the factor that the 1 came from. So the fact that I'm showing that I can work down and get the factors of the zeros that I think they are, that confirms that they are. So this is algebraically showing what I essentially already knew looking at the Desmos graph. If I go back to the graph, again, don't care about what's happening on the left side of the graph because you can't make negative lamps, right? On the right side, they start turning a profit once you pass through 1. So that means at least 1,000 lamps need to be produced. And they make a profit all the way until they make 11,000. Once they make more than 11,000, they're not making a profit. So anywhere in between 1 and 11,000, they are making a profit. So that is the answer to the question that was being asked here. Again, if you're a company, you probably want to know not just where you make a profit, but what maximizes your profit. And again, that's something that we'll work towards. But for right now, I can at least say they'll make a profit between 1,000 and 11,000 sold. All right, that's it. Let's try the next example now.